Hello, students. So, the paper which came on the 2nd of August 2023 was just bit typical compared to the previous year papers, but each and every question, the concepts were the same and language was a bit different. So, let us see how to solve this paper. It consisted of a total of 70 marks. Time given was 3 hours and consisted of 3 sections. Section A, B, and C. The section A carried 2-mark questions and B and C were 7-mark each. Now, section A were having 2-mark questions. So let us begin. Also, please subscribe to the channel. Let us start. In section A, we had to attempt all the questions carrying 2 marks each. First, can Compton effect be observed with visible light? Explain briefly. Now we know that the Compton effect is given by del lambda equal to h upon m naught c into 1 minus cos phi. When the case of visible light comes, then this difference del lambda is very small and it is undetectable. That is why Compton effect is not observed in visible light. What was the objective of conducting Davison-Germer experiment? Davison-Germer experiment was performed to verify the wave nature of electrons, and it was experimentally a demonstration to conclude that electrons exhibit wave nature also, right? So 2 marks for that. Differentiate between conduction current and displacement current. Conduction current is due to the flow of electrons in the circuit, and displacement current is due to time varying electric fields. These 2 words are important: flow of electrons and time varying fields. Now, this question has been asked so many times: why 2 independent light sources cannot produce interference pattern? They cannot produce interference patterns because the necessary condition for interference pattern to exist is coherent sources, and independent sources are not coherent sources. Hence, they will not be having the same phase or constant phase difference for fringe pattern to occur. What are the changes that are caused in diffraction pattern if the number of slits is made large? See, if we are increasing the number of slits, then more rays will be overlapping with each other and we will be getting a good, sharp, bright fringe pattern. What do you understand by stimulated emission of radiation? Stimulated is the necessary condition for laser action to occur. So, when an electron is in a different energy level of the fundamental level and it is returning back to the ground state through an incident photon, then a new photon will be generated with exactly the same frequency, direction, and phase to the incident photon. 2 marks for that. What do you mean by quantum well? Quantum well is a nanometer thin layer which can confine typically electrons or holes in the dimension perpendicular to the layer surface. So this is also section A. Now section B is 7 marks. These 7 marks are having a breakage. Suppose it is definition and numerical, then 2 marks for the definition, 5 marks for the numerical. If it is breaking up, then the breakage will be there for the questions. Now, discuss any 3 physical phenomena which could not be explained on the basis of classical physics. So you are basically dividing 7 marks into 3 equal parts. That means say 2.5, 2.5, and another leftover marks. So the common effects which failed to explain on the basis of classical physics are photoelectric effect, black body radiation, or as you remember that in photoelectric effect, the is independent of the intensity of incident radiation and is depending on the frequency of incident radiation. This was clarified on the basis of quantum physics. Then the black body radiation, various frequencies emitted during radiation are dependent on the oscillation of electrons in space. And classical physics was again failing to explain this concept. That is why quantum physics came into being. Now, state and explain Stokes' theorem and divergence theorem. You can also do it if you were knowing these two theorems in mathematics. Anyways, they are very simple theorem. The Stokes theorem is trying to change the surface integral of the curl of a function over a surface bounded by closed surface is equal to the line integral of the particular vector function across the surface. That means integral f dot dr is equal to integral of del cross f into ds, where C is any closed surface, S any surface which is bounded by a curve C, and F is a vector field. Gauss' law states that the electric flux over an area is equal to the total charge enclosed by that flux over the passing area divided by epsilon naught. And these two theorems are very important in electromagnetic theory. Newton ring experiment has been asked many number of times, but this time they asked you to explain how you can use the concept of Newton ring to determine the refractive index of a liquid. So again, you have to draw the diagram, because with this diagram, it will fetch you easily good number of marks, and then you will explain how the rings are formed with air and then with the liquid whose refractive index we want to determine. We will be placing a few drops of that liquid between the plano-convex lens and plain glass plate, and once again we are going to find out the diameters with refractive index and divide the diameter difference with air and liquid to get the refractive index with the help of Newton ring experiment. This can also be said to be a practical application of Newton ring experiment. Define a relative refractive index of an difference of an optical fiber and show how it is related to numerical aperture. See, a measure of the relative difference in refractive index between two optical materials is known as the refractive index difference, which is equal to n1 square minus n2 square upon 2n1 square, where n1 and n2 are basically the refractive index of core and cladding. What is numerical aperture? Numerical aperture is defined as the sign of the acceptance angle. That is NA equal to under root n1 square minus n2 square. And we have to very simple way just put into this formula, and we get numerical aperture is equal to 2 times of n1 square n1 under root 2 times of the fractional refractive index change. What do you mean by superconductivity? Discuss high temperature superconductors and some potential applications. Superconductivity is the property of certain materials to conduct electricity without any energy loss, and when they are cooled below a certain critical temperature, they start showing the property of superconductivity, and they are also having the property of dimagnetism. That means they expel magnetic fields as the transition to the superconducting phase takes place. Now, with high temperature superconductors, or HTS, they are materials that become superconducting at temperatures well above a few Kelvin. And some high temperature superconductors are in the very high range, and they have been used in many kinds of devices such as resonators, filters, etc. And they show the property of superconductivity at high temperature. Distinguish group velocity, phase velocity, establish a relation between them in dispersive media. What will be the relation between these velocities in non-dispersive media? So again, 7 marks are getting breaked into 2, I think, then 3 and another 2 marks. So waves can be in group, such as groups are called wave packets. So the velocity with which a wave packet travels is called a group velocity, and velocity with which a phase of a wave travels is called phase velocity. For relation between the two, it is very easy. Phase velocity is equal to omega upon k, where omega is the angular velocity and k the wave number. And for group velocity, d omega upon dk, simple, you differentiate, and k is wave number, which is equal to 2 pi by lambda, where lambda is wavelength. Hence, Vg is equal to Vp plus 2 pi by lambda into dVp upon d into 2 pi by lambda. Simplify the expression, write it in a more simple manner as Vg, that is group velocity, is equal to Vp, that is phase velocity, minus dVp by d lambda. Now, from this expression, we will give the answer to their question where they are asking about dispersive and non-dispersive medium. That means in dispersive medium, the wave velocity is frequency dependent, and in non-dispersive medium, where Vp is constant, or the free space case, group velocity is equal to phase velocity. You will get on your remaining 2 marks here. Or you can simply even write it like this for dispersive and non-dispersive medium. Solve Schrodinger equation for free particle in one-dimensional box and show that energy eigenvalues are discrete and then a numerical. So I think it must be a breakage of round about 5 and 2, because the numerical is very easy. So you will solve the particle in one-dimensional box case in detail, where you will find the value of these two constants A and B. You can refer to the lecture series and get the answer. And the numerical, I will show you in detail how it will be done. See, an electron is trapped in one-dimensional region of length 1 angstrom. Find the amount of energy that must be supplied to excite the electron from ground state to first excited state. We will use the formula for eigenvalue En equal to n square h bar square pi square upon 2ml square. Simplify this formula by putting the value of h bar equal to h upon 2 pi. Here I have introduced C up and down, so that straight away I can write the value of the energy that they are asking for. And then for ground state, n is equal to 1, so E1 is equal to this much. First excited state, n is equal to 2, and then the energy difference. And we get the answer. Derive electromagnetic wave equation in free space. Now, free space condition, even if you have specified it, that means no charges present round about it, you will fetch your 1 mark. And then the very simple derivation, you can refer in detail to the electromagnetic field theory lectures. And numerical, See, the numerical is a very simple numerical based on your famous pointing theorem only. And here they have just changed the wordings and written that energy is coming from the oscillator. So area on which the energy flux falls is 4 pi r square. R is given as 5 meter here. Energy flux per unit area is equal to this much upon area. And from pointing theorem, S is equal to E cross H, and E upon H is approximately, even if you have written 377, it is also correct. And then individually, I will solve it for E and H and get my respective answer. Next, skin depth, necessary formula for it. So your definition of skin depth will carry round about 2 marks. Formula will carry 1 mark each. That makes it 3 remaining marks for the numerical. So skin depth is the depth at which the electromagnetic signal attenuates to 1 upon E or for value, and it is measured in meters. So you can just show the exponential graph like this. There are many formulas for skin depth. The most common one you can pick up, that skin depth is equal to under root rho upon pi f mu, where rho is resistivity of the material, f is frequency, mu relative permeability, and skin depth for good conductor, where conductivity is sigma and permeability mu, frequency omega or f is given by del is equal to under root 1 upon pi f mu sigma. For dielectric or insulator, the skin depth is independent of frequency, and del is equal to 2 upon sigma under root epsilon upon mu, and epsilon is permittivity. Calculate the skin depth for silver at 10 to the power of 8 hertz frequency. This is a very simple numerical. You just have to put the values in the formula. Del is equal to under root 1 upon pi f mu sigma. And be careful while solving the question. The trick is there lying in the solution of 10 to the powers, and pi is 3.14. So this 10 to the power of minus 7 and this 10 to the power of 7 will get cancelled, and straight away you just have to find out the square root. Expression for fringe width for wedge-shaped film. Now wedge shape has been asked many number of times. Detailed explanation you can refer to my interference lecture series of how you will be getting the answer for the wedge shape. Along with that, wedge shape part difference is 2 mu t cos r plus theta plus lambda by 2. They are asking you to discuss how the fringes are getting formed. So when it is illuminated by parallel light, then straight fringes parallel to edge will be obtained, and loci of all points of constant thickness is straight line, and hence we are getting straight fringes. Numerical, a light of wavelength 6000 angstrom falls normally on a slit of width 0.1 mm. Calculate the total angular width of the central maxima. Now see, total angular width of central maxima will be twice the angle made by the first minimum with the normal to the slit. So angstrom, 1 angstrom is 10 to the power of minus 10 meter or 10 to the power of minus 8 centimeter, and sine theta is equal to n lambda upon a. And we put the values which have been given to us in the numerical. See to it that all CGS, MKS have been converted properly, and we get the total angular width. What particular spectra would be absent if width of transparencies and opacities of the grating are equal? This they are just asking you in detail the condition for absent spectra. in diffraction pattern. So the grating equation is E plus D sine theta equal to n lambda, where n is 0, 1, 2, 3, and single slit E sine theta equal to m lambda. Now if D is equal to E, then n is equal to 2m. So these are the spectra which are going to be absent, corresponding to the minima due to single slit. This is what they are asking you, a more detailed explanation. A plane transmission grating is having 16,000 lines to an inch over a length of 5 inches. Now in this line, do not get confused and divide it by 5. Read the line again. It is saying 16,000 lines over a length of 5 inches. And in grating, we use LPI. That means the total number of lines will be 16,000 into 5. And second order spectra, n equal to 2. Lambda, you can change it straight away. It will be in centimeters, and put the values here and get the answer. What are solid state lasers? Explain construction and working of ruby laser with suitable diagram. Every year, either ruby laser or helium neon laser comes. It's a very regular trend. So solid state laser is a laser that uses a gain medium that is solid rather than a liquid. And then very detailed ruby laser you can explain. This whole detail you can check in my laser series. Now, discuss the important factors that are responsible for the loss of power in optical fiber and numerical. So you can do the breakage as roundabout 4, 4 for each. Optical fibers will basically be suffering radiation losses at bends or curves on their paths because they are based on the principle of total internal reflection. And their main losses you can characterize as absorption losses, scattering losses, dust and microwave fluctuations in core diameter, core cladding boundary imperfections. You can just sum it up or draw the chart like that. Now numerical. See, loss per kilometer in decibels. So this is kilometer. You don't need to change it into meter. So the answer is minus 10 upon L log base 10 output power upon input power. Simply put the values, approximate log base 10 30 value, and this is 0, and you get the answer. The numerical is very simple. Formula will carry marks and the steps. Discuss the effect of external magnetic field on superconductors. The transition temperature, and this is given. This numerical obviously is a very common numerical of superconductivity. Hc equal to H naught into 1 minus T by Tc whole square. They have given you the values. You simply have to put them in the formula and you get the answer. Discuss properties and potential applications of nanomaterials. What are the risks of using nanomaterials to human body? Nanomaterials are materials less than or equivalent to 100 nanometers, and the nanomaterials are made of metals, semiconductors, oxides, and have been used as quantum dots, chemical catalysts, etc. But they are now biggest risk is of medicines, drugs, cosmetics, where they can be toxic to the human body. Still research is going on with nanomaterials potential being so small in size to move from lungs to other organs such as brain, liver, etc. because of their small size. And since a lot of research is still going on, inhalation of nanomaterials can be also very harmful for the lungs, etc. of human body. Cosmetic products made from nanomaterials can also be harmful for human skin. So, thank you.